Let me talk in this video about how we could find the complexity of a code. So to find code complexity, there are three rules we need to learn about the code complexity measurement. First one, if you see add operation, subtract operation, multiplication operation, or division, or if statement, all these will take one step to run. One step to run. That means constant time. We could name it C, constant. Okay? If you see in the code, there's a memory access, and when I say memory access, you could think about it as someone reading variable from the memory, writing variable to the memory, update variable from the memory. All these take also one step to run. So all these also take constant time to run. If you see in the code there is a loop or there is call for subroutine means function or method, this will take n step to run. Okay, n step. Name it n. So loops always take n because you don't know how many elements in the, well, you know 1 to 10, but we define a loop as you don't know for some scenarios. For someone send the last element in the loop as a optional. But subroutine we give it n for different reasons. Because we don't know what will happen in the subroutine, so by default we give that call as n time. Sometimes the subroutine have only one call. Yeah, that is you give it constant time. But when you see a call for subroutine in the code, you definitely give it n because you don't know how much time it will take. When you see a loop, you give it n. When you see memory access or add, subtract, multiplication, division, if statement, you give it constant time. So very, very simple three concept. Let me test now your knowledge. Let me see how you understand this. If I suppose I have integer sum equal 0, then I have a for loop for I equal 0, I less than n, then I plus plus. I wouldn't say I less than 10 because if I say 10 it will be constant. I will say n. So whenever you see this, now someone asks you, hey, could you measure the complexity for this code? You say, okay, yeah, it's not hard. First line, look to me, is just defining variable and accessing to memory location, so I give it constant. And because it's the first constant, I give it C0, because if the code may have multiple constants, so I give 0, 0, Z1, C2. And the second line is just a loop, and loop for our concept, it take n time. If I want to measure the complexity of this code, I have C0 plus n. Then I say equal, okay. Based on the big O definition, we take the worst case. So which one worse? Is the CO worse or n worse? No, the n is worse. So the code complexity here is n. So again, in the big O, if we have multiple options, we add them, we take the worst one, the highest one. And we discussed previously how the highest should look like to you as a researcher. So now if I just try to make this example more complex, I try to say, no, I would assume here in the for loop there is some operation, and in the sum I have sum plus I. Okay, now, hey, measure the complexity. Again, the first line is still C0, the second line n, and this one is adding, the third line is adding operation, so because it add, so it is constant time, so I say constant, I have 0, I should go to the next, which is 1. Now my code will be C0 plus n. But now I have C1 is part from the n. Whenever you have anything in the loop, it should be multiplied by the complexity of the loop. Multiplied by C1. Why? Because it is part from it. It runs exactly the same time amount of the loop run. If the loop run for 10, it will run 10 times. If loop run for 100, it will run for 100 times. So now, what the complexity? I have to add. So I have left side and right side for here. So here I have C0 and I have n plus C2. C1, so the complexity should be the highest, and the highest here is n multiply or n C1. C1 is always constant, so you don't take it, so you will take the complexity here still n. We did not change anything. We still have n complexity until now, but we add different variables here. Now let me make the code more complex by say no, I would have another loop inside this loop before I do the add operation. That's mean, hey, I want to add another loop before I do sum. That's mean, yeah, okay, I would go with you. I say, okay, I have another loop here, and inside this loop I have j equals 0, j less than n, j plus plus, and I have sum equal sum plus I multiplied by j. Okay, that's good. Now what's the complexity here? Okay, we go to the same concept. First line takes C0 and the second line, this one again loop, it take n time. This one constant takes C of 1. Now let me measure it. Just remember this one inside this one, and this one inside this one. That means this one multiplied by this one multiplied by this. Anyone inside loop should be multiplied by it. So I have C0 alone plus n multiplied by n multiplied by C1. So now what you say? You say, okay, C0 stay as it is. N multiplied by n will be n squared C1. So C1 multiplied by n squared. Now we got the concept of the big O. Big O, who's the worst? Is this one the worst or this one the worst? So definitely this one is the worst. So the worst is C1. Let me erase the pen. The worst is C1 and multiplied by n squared. Again, it's constant, we don't take it, so the complexity is n squared for this code. Let's go and make the code more advanced. So I would say, okay, no, I don't care for these 3, 4. Now I would add another loop, and this loop have nothing to do with the previous loop. It's the independent loop, so which is supposed to be here for k equals 0, k less than n, then I say k plus plus. Then I say sum equal sum plus k. Okay, now measure the complexity. Okay, first one 0, this is loop, should be n time, this one loop, n time, this one constant, C1, this one loop should take n time, this one constant should take constant C2, because I have C1, I have C0, C1, should have C2. By definition, this is inside the loop, it multiply, this inside this one, it multiply, this one inside this one is multiply, and this one alone. So the code has 3 pieces, this piece, independent, and this piece. So this one should be C0, this one should be n multiplied by n multiplied by C1, and this one should be n multiplied by C2. So if I just do it as a mathematic, I have C0 plus C1 multiplied by n multiplied by n plus C2 multiplied by n. Now let's go next. C0 stay as it is, C1 stay as it is, n squared, here will be n by n plus C2 multiplied by n. Now based on the concept of the code complexity, who's the worst? Is C1 or C0 or C1 n squared or C2 n? So definitely this one is the worst. So these two I don't care about them. So the worst case for me here is C1 n squared. And this is constant, I don't take it. So the worst case for this code to run, it take n squared time. See, the worst case, we don't care about the small pieces. We care about the worst place in the code, how much time it will take to run. So that's good. For now, let me take more examples. If I just say no, let me just clean this, because that's a lot to clean one by one. If I assume I have a if statement, which is the last part in this section, how I deal with if statement. If statement mean I have someone define integer sum equals 0, then he define a loop for I equals 0, I less than n, I plus plus. Then I say, okay, I have open bracket, close bracket for my loop. In the bracket, I have if statement sum equal, for example, sum equal 10. I will do some operation, which is sum equal sum plus 2. Otherwise, I would say sum equal sum plus I. It's just I'm adding loop, just make my code more complex, and I want to measure the complexity. This one, first line, will take C0 to run. This is loop, take n time. This is if statement, take C1, constant time. This one again, access memory, take constant time, C2. This one take constant time, which should be what? Should be C3. All these three inside the loop, that means 3 of them multiplied by the n, and that one alone. So I have C0 plus n, the loop, multiplied by C1, and let me assume this as one block, and this one alone. So the one block, if you see this one inside this one, anything inside the loop, it will run only if the loop run. If the loop did not run, it will not run. But by the end, all the times I have the loop there. So all the time the loop, sorry, let's make it clear again. If I have if statement, always we will check for if the sum equals 0. So always we have a constant time C1. But C2 not necessarily have it all the time. You may have it or may not have it. We may run this code and this one get executed, and we may not. So we just add it as a plus C2. So whenever you have if statement, the content of if statement will be as a plus to the if statement. And I have plus C3. Okay? Now all this one, C0 stay as it is. This one, N1 plus all these. Who's the worst? Just look through the code. The C0 or n multiplied by all these. Definitely n multiplied by all these is the worst. So n multiplied by all these is, just make it a pin. N multiplied by C1 plus C2 plus C3. And as we know, the constant, we don't take them. So the code complexity here is n time to run. Just again, just as a review, whenever you have any memory access defined, you just take constant time. Variable if statement, constant time. You have loop, the loop will take n time to run. Okay? Even if this is a big discussion, you say, hey, what if this one have a number 10? I know this loop will run for 10 times. Yeah, I know this is because you hard coded, but definitely the loop should take n time. People don't know how much elements should go through to search. And in the real world scenario, you say, okay, I'm searching for 10 numbers. So okay, the 10, this is like the big discussion I have in this course. People say this. You say, okay, why you here saying loop always take n? For example, I'm searching for 10 numbers. I have 4, I equals 0, I less than 10, I plus plus. I'm searching, for example, if I equal 3. You say, okay, this is constant, this even loop, but it's constant time. I know it takes 10 times. But you are searching for 10 numbers only. In the real world scenario, you don't supposed to know how many elements to search for. I mean, in the companies like Google, when they search for hundreds document looking for the information. So always this one should be n in your definition. Even if constant, I would say give it n time to run. Whenever you have loop, you say this is n. This is how we talk with your interviewer. Just don't tell him this is constant, because you may not get the job. So just make sure whenever you use a loop, say, okay, this is take n time to run. So here we're done. Thank you for watching, and see you next.